Good morning, everyone. As promised, we will have some supplementary lectures on lot area computation. So let's start out with area by triangles. Now, there are different methods depending on the given values or the measured values in the field. So the first case is the known base and altitude. So we know this formula very well now from our math lectures in high school, and also in our pre-calculus. This was also discussed, no? So area is equal to 1/2 base times height. Okay, so the base in this case is the length of AC, and the height is the length measured from B to AC, perpendicular to AC. Okay, so let's go to the next one. So this is just a sort of review. So we have two sides and included angle measured. So the included angle here is alpha right here, and the two sides are A and B. And now the formula is area is equal to 1/2 AB sine alpha. Okay? Okay, finally we have the three sides measured. Okay? So the area here is equal to the square root of S times S minus A times S minus B times S minus C, where S is half the perimeter, or A plus B plus C divided by 2. Okay, so as you can see here in the figure, we have the lengths of the sides A, B, and C, lowercase a, b, and c. Okay, so let's apply these methods. Also, let's see which method we're going to use here to an example. Okay, so let's read the problem. A surveyor sets up a transit at P, which is located in the middle portion of a four-sided tract of land, and reads directions and measures distances as given in the table below to the corners. Now find the area of the tract in square meters. Okay, so the first thing that we need to do here is to plot this tract of land. We are given the bearings and distances from P to the different corners. Okay, so let's start by drawing P. Okay, so we have right here. That's a lot bigger. Okay, so again, we have, sorry for that, that's really, okay, sorry because it's not that straight. Okay, so this is A, and 410.52, and then we have right here 41 degrees 30 minutes. Okay, so let's now move on to B. So north 38 degrees 10 minutes east, so 532. So let's see. So it's longer. So it's longer than PA, right? It's longer than PA. So let's draw it here. A little bit longer than PA. So actually, it's a lot longer, 100 meters longer, approximately. Let's draw it like that. And then we have here, this is B, right? And then the angle here is 38 degrees and 10 minutes. Okay, and the length, let's not forget to write that down. 500, and let's write that down properly. 532.18 meters. Okay, let's move on to PC. So south 70 degrees 20 minutes east. 70 degrees 20 minutes east. So what's that? So that would be about here, and it's 450. So let's see. Okay, so let's estimate it to be there, and then C, and then the length is 450.75, and then we have our angle 70 degrees 20 minutes. Okay, so let's now move on to the last one. South 60 degrees 15 minutes west. Okay, and 590. So it's the longest one, the longest line right here. So right here, so let's see D, and then 590.08, and then we have right here 60 degrees 15 minutes. Okay, so now let's connect all of these using a proper line here. Okay, so okay, so now that we have our figure here, so let's see what method we can apply here. So after looking at all of the given, you can immediately see that it is method 2, right? Two sides and included angle measured. Okay, so now let's do the computations. So the first thing that we can do is to compute for the missing angles right here. Okay, to make it easier for us in the calculations. So we have here angle. Okay, so let's write it here in the side. So we have angle AP. Let's write out P first so that there are no confusions here, no? So this is point P. So APB, angle APB. APB is equal to 41 degrees 30 minutes plus 38 degrees 10 minutes. Okay, so that will be equal to 79 degrees and 40 minutes. 79 degrees and 40 minutes. Okay, so how about angle BPC? Angle BPC. So this is equal to 180, right? So 180 degrees minus 38 degrees 10 minutes and then minus 70 degrees 20 minutes. So why is this? Because we have this. Let's write it. So we have this, no? This is 180 degrees. Then we have these two angles here. So to get this one, 180 minus this one and this one. Okay? Okay, so the answer here is 71 degrees and 30 minutes. 71 degrees and 30 minutes. Let's move on to the other two angles. So we have angle CPD. CPD is equal to 60 degrees 15 minutes plus 70 degrees 20 minutes. So what is this? What is the sum of this? So we will get 130 degrees and 35 minutes. 30 degrees and 35 minutes. And then finally, we have the angle APD. APD, which is equal to 180 degrees minus 41 degrees, 30 minutes, and then minus 60 degrees and 15 minutes. So what do we get? We get 78 degrees and 15 minutes. Okay, very nice. Okay, so let us now start computing for the areas. Okay, so let's just copy this, no? Let's just copy this figure downwards. Okay, so now that we've copied it here for reference lang, no? Atong gi-scale down. Let us now find the areas using the method 2. Okay, so let's just write out the computed angles here that we already have. So we have here BPC is, this is 71 degrees. 71 degrees and 30 minutes. And then we have APD is 78 degrees and 15 minutes. Okay, very nice. So let's now compute. Let's now compute for the area of triangle APB. So what's that? So that would be 1/2 410.52 times 532.18 multiplied by the sine of our alpha here. So this is 79 degrees and 40 minutes. Okay, so the area should be 107,463.56 square meters. Okay, so you can try that out for yourself. And then BPC, let's now compute for BPC. So that would be 1/2. So what are our sides here? 532.18 multiplied by 450.75, and then sine our alpha here, which is 71 degrees and 30 minutes, right? So we should get 113,742, okay, 0.00 square meters. Okay, so we are only using 2 decimal places here, because in our given here in the lengths we only have 2. Okay, so let us now proceed. Area of CPD. Okay, CPD is equal to 1/2 of 450.75 multiplied by 590.08, and then sine our angle, which is 130 degrees and 35 minutes, and that will equal to, we should have 101,000.12 square meters. Okay, so now finally we'll have angle APD. Okay, this is the final one. So area of APD is equal to 1/2 of 590.08. Oh, sorry for that. 0.08 multiplied by 410.52, and then the angle is 78 degrees and 15 minutes. So we should get 118,581.81 square meters. Okay, so now it's just a matter of adding all of these areas. So let's just add all of these. And you will get a total area. You'll get a total area of 440,787.49 square meters, or 44.0787 hectares. Okay, now why is this? Because 1 hectare is equal to 10,000 square meters. So you just divide this by 10,000, you get the value of the area in hectares. Okay, so this is our answer. That's the application of method 2 here. So you can try it out for yourself, no? You can compute for the sides. So you can compute for, you can use the Heron's formula here as well. You can check. You can use the, you can compute the sides here. So you can compute these sides using the cosine law, right? Because you have the angle here and this one. You can compute this one. I can compute all of them. And then you try to compute the area using the Heron's formula, using all these 3 sides, all of the sides that you have right here for the triangles. So you see, try if you can get the same area. Okay, so obviously there will be some differences because here we are only using 2 decimal places. So for your computed lengths here, you can use 3 decimal places, and you can finalize your answers in 3 decimal places. Definitely it will be close, but it will not be exactly the same. There will be some differences there. Okay, but if you divide it by 10,000, it will be the same because 44.0787. Okay. Okay, so thank you for watching this video. I hope you learned something new, and if you have any questions, please don't hesitate to ask using email or through our Google Forms. Okay, so thank you for watching, and I'll see you guys next time.